Hi all, let me introduce myself. I am Kiran. Welcome to my YouTube channel Web of Wisdom. Thanks for joining. In this channel, we will cover various tutorials related to Java, Spring Boot, and microservices. In today's session, we'll see various cache strategies and their implementation using Java, Spring Boot, and Redis. For implementation, we'll be using following tools or technologies such as Java 17, Spring Boot 3, Maven 3, Spring 6, and MongoDB. So today we'll see what is meant by cache. Then we'll go for what various cache strategies and hands-on on those cache strategy using Java, Spring Boot, and Redis. So to understand what is meant by cache, we need to take sample example of a web application as shown in figure, where browser acts as a client and web server acts as a server. Whenever there is any request for page from client, that request will be served by server. But in case there are requests for same page from client to server, at that time the client will send similar request and server will send the similar type of response. To optimize this functionality, cache is used where whenever there is a request from client, the data will be looked into cache, and if it is uh, data exists in cache, it will be turned to client. Otherwise, there will be a request made to the server. Now we'll see what are the various cache strategies. First is cache aside and read through. Actually, cache aside and read through are similar strategies. That's why I have segregated then in a single category. Next is write through cache strategy, write back or write behind cache strategy, and write around. So first, now we'll see cache aside and read through strategy in detail. So in case of cache aside and read through strategy, cache is deciding between application and database. Whenever there is a request from application to database, that will go through cache. If the data is available in cache, it's called as a cache hit, that will be returned to the application. If data is not available in cache, then request will be made to database, and data will be cache will be updated, and after that it will return to application. So that is nothing but cache miss. So this type of strategy mostly used in read heavy workloads. There are certain advantages of this cache strategy. First is resilient to failures. Resilient to failures means if database fails, then data can be fetched from cache for some time. And another advantage is data model can be different for cache and database. So there are certain disadvantages of also of cache aside and read through strategy. One is stale data provided in case of database updation. So what is mean by stale data? For example, there is an application that is requesting data from cache, and during data retrieval, if there is any update operation performed on database, at that time cache will return the old or stale data. To handle this situation, we can use data invalidation using time to live, or we can use another cache strategy. So in previous slide we have seen the working of read through and cache aside. Now we'll see differences between the read through and cache aside. The main difference between read through and cache aside strategy is that in case of cache aside strategy, the application is responsible for fetching the data and populating into the cache, while in a read through cache the logic is done by a library or some separate cache provider. Another difference is that data model in read through must be same as data model in database. In case of cache side, the data model can be different. So we'll next move to the another cache strategy, and that is the write through cache strategy. In case of write through cache strategy, the data will be returned to cache only if data returned to database is successful, and once both the write are done, it will be considered as the successful operation. And there are certain advantages of write through cache. One is full data consistency, as we are writing data to cache as well as database. There will be full data consistency. There are certain disadvantages also for write to cache strategy, that is higher latency, as we are writing data to cache as well as database. There will be higher latency. The next cache strategy is write back or write behind cache strategy. In write back or write behind cache strategy, data will be read and write to cache, and it will be write to database asynchronously. There are certain advantages of and disadvantages of this approach. First, we will see the advantages. This type of cache strategy is suitable for very heavy workloads, and another advantage of this cache strategy is that some database failures can be tolerated in case of failures. It means that if we write data to cache and similarly we write to database data to cache, we don't, and if there is a database failure for some time, that will be handled using cache. But it has some disadvantages also. In case of cache goes down, there will be data loss. The last cache strategy is write around cache strategy. In write around cache strategy, during read operation, data will be read from cache. If data is not in cache, that data will be fetched from database and cache will be updated. In case of write operation, data will be returned to database. There are certain advantages of write around cache strategy. This cache strategy is good for write heavy workloads, and some database failure time can be tolerated in case of failures. Similar to previous cache strategy, it has disadvantages, certain disadvantages, such as slightly higher latency in case of write operation. So we have seen all the cache strategies theoretically. In next session, we'll be looking at how those cache strategies can be implemented practically using Java, Spring Boot, and Redis. So in previous slides, we have seen theoretical knowledge related to cache strategies. So in this section, we'll be looking at how to implement those cache strategy using Java, Spring Boot, and Redis. So for that purpose, we'll be following some steps. First, we will create a CRUD REST API for user entity, and then we will be adding Redis as a dependency, Maven dependency, and then we will be go for implementation of various cache strategies using annotations except write back strategy. And for write back cache strategy, we'll be using reactive programming and Mongo. Next, we will see major annotations used in implementation of Spring Boot and Redis cache strategies. So first is enable caching. Enable caching is a application level annotation. Whenever we want to use caching, and we should annotate the main class with at the rate of enable caching. Next is cacheable. Cacheable is basically used to cache the result of particular method, and during first call of that method, it will be written, data will be saved into cache, and next time that data will be written from cache. Next is cache put. Cache put is basically annotation, method level annotation, which can be used to update the data in cache. Cache with this annotation is also method level annotation, and it indicates the cache entries associated with the annotated method should be removed from the cache. Means it's basically used to remove data from the cache. Next is caching. This annotation is used to apply multiple cache related annotations to a single method. For example, if you want to annotate caching and caching eviction, at that time we can use at rate of caching annotation. And the last one important annotation is cache config. This annotation is a class level annotation. It is basically used to specify default cache configuration for all the method in the class. For example, we have five methods in class, and we want to apply some common configuration to those methods. At that time we will use cache config. So in previous slide we have seen what are the various steps related to implementation of various Redis cache strategies, as well as we have seen what are the important annotations required. In this session we'll be dive into the practical. Means we'll be creating one application that will be used that can perform CRUD operation for user entity. So I have used those dependency pom.xml dependencies, Spring Boot Starter Web, Spring Data GPA. As I am using Spring Data with MySQL, I am using MySQL connector dependency, as well as I am using Lombok. Um, Other than this, I have created user entity class. Here I am using various attributes such as ID, first name, last name, and email. And for those user entity, this is the user entity. I have created user repository, user service, and its implementation. Also, I have created a controller class. So let us try to execute this code. I have already tested this code. Let me start the server. So the server is started. For testing the APIs, I am using Postman as a tool, and I have already added one user in database. So this is a sample user. This user we can verify in the database. As you can see, that user is available in database also. So to implement the caching in our application, first of all we need to add one dependency. That dependency is nothing but JDIS. So basically, JDIS is a Redis client. Other than JDIS, there is one more client available that is called as the Lettuce. We are using JDIS client because it supports the synchronous as well as asynchronous request to Redis. There are certain differences between Redis and Lettuce. Lettuce is more advanced one, and Lettuce is uh, a big topic that we are not covering here. So let us go to the main application. So to enable caching for our application, we need to use enable caching annotation. Other than that, we need to add some configuration related to caching. So I have added some configuration related to Redis template and JDIS connection factory to enable caching in our application. So basically, first configuration is used to set key serialization value serializer for Redis template and also the connection factory. So as we can see, there is another bin JDIS connection factory. Here we are setting host name and port name for Redis. So we have added basic configuration for Redis. Now we will update the service IMPL file to enable caching. So in previous section we have discussed various annotations related to caching. So one of the annotation was cache config. So cache config is basically used to perform the similar configuration that is applied to all the methods in a Java class. So first annotation we will add is cacheable. So cacheable is used cacheable is used to cache the result written by the particular method. For example, here we have applied cacheable to find by id. Whatever the result it will be getting from find by id from repository, it will be cached. So to use cacheable annotation, we have two parameters. One is value and another is a key. So using this annotation, we will be caching the result returned by the find by id. Means here, what will happen when user first executes this method? Data will be returned from user repository that will be stored into cache, and on further request, data will be returned from cache only. So next is cache put. So as we discussed earlier, cache put is basically used to update the result in cache. It takes one argument, that is key. Next is delete all users and delete by delete. So for those methods, we'll be using cache width. Cache width is basically used to remove the results from cache. So we'll be passing one parameter here, that is all entries is equal to 12 true, because we are passing this um, parameter because we need to delete all the result from the cache. Similarly, for delete by d, we will be applying cache width, and also there will be only one argument, that is key, and we are removing only one entry from cache, so that will be user.id. So let us test the application. For testing the application, we need postman as well as with postman. So let us test the application. So first I will start the application. Start the application. As you can see, the application is started. So let us test one by one endpoint. So let us test the APIs. As you can see, we are testing the get all users API. I already added one user here. So let me test the get user API. So we are getting internal server error. This is we are getting because we haven't configured the default serializer. So we are getting error. Default serializer requires a serializable payload. Okay, so let us add the code for default serializer. So let me add code for default serializer. So here I am using cache manager with Redis connection factory, and I am creating a bean and also setting the serializers and deserializers for the Redis cache. So let us restart the application. Let me clear the log. So let us test all the APIs one by one. Currently, I have created one user in database that is called with name John and spell name Smith. So let us try to get that user from get all users API. So for get all users, we have to apply the caching. As you can see in cache, there will not be any record. So let us try to execute the get single user API. For this API, we have added the caching. So the record will be updated in cache. As you can see, there is a user record in cache. Similarly, for put, when we execute uh, put method, it will update the record in cache as well as in database. So let me correct the ID. So as you can see, the record has been updated in database as well as cache. So let me open the cache. As you can see, similarly, we can execute the delete and delete all methods. So just we have just seen the working of uh, cache aside strategy using Spring Boot. So now we'll be looking at right through cache strategy implementation using Spring Boot. As we have discussed earlier, in cache right through cache strategy, data will first return to cache and then it will be returned to the database. So for implementation of right through cache strategy, I have used Redis template. So Redis template is basically used to interact with Redis cache. Here I have modified the code for find by ID method. Here I am checking whether that data or user is present in cache, Redis cache, and if it is null, I am fetching it from database and saving it into Redis cache. So for I also modified the save user method. Here what I am doing, I am saving data into cache and after saving to cache, I'm saving data to repository. So let us test the application. So to test the application, let us start the application in debug mode. Here I have added some breakpoints to test the application. So let me first clear the log. Also, I'm showing the cache as it is empty. So when we find by ID API, so initially the the object will be null, which we fetched from Redis cache. As you can see, user object is null, and if it is null, it will be fetched from repository and it will be saved to cache. So before we check the database contents, we'll check the cache contents. So as you can see, it's not available in cache. Now the user object is fetched from uh, database and it will be saved into cache. and that object will be returned to user. So in this way, write to cache strategy work. For save user means save or update, the cache will be updated first and then database will be updated. So the next cache strategy is write around cache strategy, where write operation always happen to database and read operation will be fetched from cache. If the data is not available in cache, data will be fetched from the database and cache is updated. So to implement the write around cache, we can use Redis template and we can implement in similar manner.